Hey Trig, this is section 3.5, operations on functions. I'm going to separate this into two videos. So we'll do the front side now, so it'll be kind of a shorter video. Back side we'll do tomorrow, and then that will be the rest of the week. So starting with operations on functions, I went ahead in example 1 and I changed f of x and g of x to two different functions because I want to start off with kind of an easier example, and then in example 2 we'll get kind of something that's a little bit harder. So change those functions, rewrite them. F of x is x plus 6, g of x is x squared minus 4. The first thing they want us to do in part A is write the rule for f plus g and f minus g. Okay, so I'm going to do that over here so we've got enough room. F plus g is basically just saying take f of x and add it to g of x. So we have x plus 6 plus x squared minus 4x. Okay, so we want to add those two together, and then we would just want to simplify and do, combine any like terms if we can. So those parentheses aren't doing anything really for the x plus 6. So I can just drop those x plus 6. And really, if I'm adding x squared minus 4x, those parentheses will be dropped as well, because if I take plus an x squared, that'll just be plus x squared if I distribute the positive, and plus a negative 4x is just saying minus 4x. So it's really just kind of like dropping the parentheses for when you're adding in between them, and then I just combine like terms. So the x squared is what I'm going to write first. X and negative 4x is minus 3x, and then I'll cross those off, and then plus 6 is my final, so that is what it looks like when I add f and g together. Okay, and then I'm going to do part B. I don't want to write too much part B. We'll just put part B right here, and we'll write smaller. So part B, they want us to do, or no, not part B. This is the second part of part A. They want us to do f minus g. So I'm going to do f minus g here. And so f is x plus 6. Then we do minus g, which is x squared minus 4x, okay? When you're doing subtraction, it's just one more extra little step, because you do have to think about distributing that negative across. The x plus 6 will not change, but distributing the negative through, negative will make that negative x squared. Negative 4 we'll change that to be plus 4x, and then we'll just combine like terms like normal. So negative x squared, I'm going to write him first. He's gone. Then I have x and positive 4x that I can add together. That will make plus 5x. So they're gone. And then I have plus 6. So just slightly different when I'm subtracting. Okay. Now I'm going to move on to part B. I'm going to do this in a different color. So part B, find the domain of f plus g and f minus g. So we've got these two functions here. And we're looking at what we are allowed to plug in for x, because that's what domain means. X means what, or domain means what x's can I plug in and what x's can I not plug in. And if you remember from a few sections ago, we had just two things that will cause domain errors, is what I call them, and that is having a negative inside of a square root or dividing by 0. Those are the two main things that I cannot have happen. Or I have to worry about happening when I'm plugging things in for x. In addition to that, we have kind of like, if you have a story problem, you can't have negative length or negative distance. So I kind of called that rule 2a, is if you have a story problem. But really, the only things that I have to worry about if I'm looking at a function is a negative inside of square root and division by 0. So if I look at this first guy and I say, what is his domain? What can I and can I not plug in for x here and here? I notice that I don't have any square roots, so I don't have to worry about domain error number 1. And I really don't have any fractions at all, so I don't have to worry about dividing by 0. So this guy, I can basically plug anything that I want to in for x. So his domain will be all reals. Okay, there's not a number that I have to worry about, positive, negative, 0. I can plug any number I want to in for x, and it will not give me any problems. Okay, same thing with when I'm looking down at this function, this second one right here. Don't have any negative inside of a square root, things to worry about. Don't have any division by 0. So his domain is all reals as well. Okay, so that gets example 1 done. A and B are both taken care of. We've simplified them. We found the domain of both of them, and there is that. Okay. Product and quotient is kind of doing the same thing. I'm going to start with f of x being this guy and g of x being this guy. And it says write the rule for f times g. That's what that looks like. And f divided by g. Okay, so we're going to look at both of those, write the rule. All right, I'm going to write off to the side over here on this side. A, we want to f times g. So I'm taking the square root of 3x and I'm multiplying that by the square root of x squared minus 1. Okay, I'm multiplying those two things together. All right, and when I'm multiplying, I can go ahead and combine stuff that is on the inside. So really, if I want to, if I'm multiplying this, I can write it all under one roof as 3x times x squared minus 1. If I was adding, I would not be able to do that. Okay, but since I'm multiplying, I can combine everything underneath of the same roof, and I can distribute the 3x through for both of those pieces. So this would be the square root of 3x to the third power minus 3x. Okay, if I multiply 3x times x squared is 3x to the third, 3x times negative 1 is 3x. And so this is what he's going to look like when I am multiplying him through. Okay, now dividing the second part of A, this is f divided by g, and that is the square root of 3x divided by the square root of x squared minus 1. Okay, and now really the only thing that I want to do with that is, because I have a square root on both the top and the bottom, what I can do is I can combine that all underneath of one square root, and he will look like this. Okay, and then you always want to check to make sure that you can't reduce anything. On this one, I have a lot of people that are tempted to cross this x out with one of those, but remember that the x squared minus 1 is trapped as a unit together, so I cannot cross those x's out, so I have to leave them. So really, there's not really anything that I can do to reduce this guy, so this is going to be as far as I can simplify him. Okay, so we've got f times g, which is what's over here, and f divided by g, which is what this guy is here. Okay, normally we don't want to leave a square root in the denominator, but I'm not going to worry about doing any of that right now where we rationalize it. So we're just going to leave our answer looking like this, and then we're going to do domain here in just a second. So the part B is where we find the domain. Find the domain of f times g and f divided by g, and this is where we're going to have some issues. So domain over here, okay? This is a little bit trickier when you have a square root and all that stuff, and really, we have a square root over here, we have a square root over here, but then we also have division by 0 here. So we've got to look at all of those pieces together, okay? So division by 0, well, let's start with this thing over here on the left side and look at what we can and cannot have for x in this case, okay? So when you're doing a square root, when you are trying to figure out what x can be and what x cannot be, the square root is the hardest one to do of the two domain errors, okay? It's the most work. This one takes a little bit more work than this one. This one you're just trying to figure out what x cannot be equal to. This one is kind of a range of values that x can and cannot be, okay? So down here, let's start by, we know that this stuff inside of here cannot be a negative number, whatever that comes out to be. It cannot be negative because we cannot take the square root of that if it is negative. So what I'm going to first do is I'm going to take 3x squared, or excuse me, 3x cubed minus 3x, and I'm going to set that equal to 0. Okay, and then we're going to solve this thing. Okay, so 3x cubed minus 3x equal to 0. The first thing that I'm going to do is I'm going to look at both of those pieces and see if there's something that I can pull out. So what I'm going to pull out is the 3x, and left over is x squared minus 1. Okay, kind of like the two pieces that we started with right here. So I'm going to do that, and then I'm going to set both of those pieces equal to 0. So this guy, 3x equals 0, and x squared minus 1 equals 0, okay? If 3x equals 0 and I divide by 3, 0 divided by 3 is still 0, so we've got that going on there, okay? And then x squared minus 1, I'm going to circle this, x squared minus 1, if I add the 1 over to the other side, x squared equals 1. And then if I take the square root, remember that the square root of 1, if we put that square root in there, is positive 1 and negative 1, so plus and minus 1, okay? Now, we have found those 3 points. And then the last thing that we have to do, this is what makes this a little bit harder to do. That's why this one is more work than the second one, is that we have to put this on a number line. So I'm going to start by putting this on a number line, -1, 0, and 1. Those are our 3 numbers that we have. I'm going to put them in order on a number line and see what numbers we are allowed to plug in and what numbers we are not allowed to plug in. Okay, so let's start with like -2 is a number that in between those two that I can plug in. -0.5 is a number that I can plug in, +0.5, and +2. Those are all 4 numbers that I'm going to plug in to this thing and see if we get something that's bad. Things that are bad will come out to be negative numbers, and I don't want to have negative numbers, okay? So let's start by plugging in my first number, which is -2. So 3 times -2 to the third power minus 3 times -2. Okay, -2 to the third power is -8, and 3 times -8 is -24. Okay, -3 times -2 is +6, so I have -24 plus 6, which is -18. Now, this whole thing comes out to be -18 when I plug a -2 in there. I can't take the square root of a -18, so that is bad. I don't want to have things that are less than -1 in my domain, okay? If I do -0.5, I'm going to erase this stuff. If I'm erasing something that you're still writing down, go ahead and go back and pause the video. Now I'm going to do -0.5. So -0.5 cubed minus 3 times -0.5. I got to grab a calculator for this. And I'm just going to enter that all in one shot. So 3 times -0.5 to the third power minus 3 times 0.5. No, -0.5. Okay, you can enter this in as well if you want to check. And that is a positive 1.125. So since he's a positive number, I can take the square root of those guys. So that is good. Okay, the next thing I want to do is I want to take positive 0.5. So I'm going to go back into my calculator. And the thing that I want to type in is 3 times 0.5 to the third minus 3 times 0.5. I'm going to change those -0.5s in my calculator to be positive 0.5s and see what it gives me as the answer. And I get negative 1.125 when I plug 0.5 in, so that's bad. And then number 2, if I plug the 2 in, so I'm going to change these to be 2s. 3 times, well, I'm just going to do this in my head here. Okay, 2 to the third power is 8. 3 times 8 is 24. Minus 3 times 2 is minus 6, and that's a positive 18. I can have positive numbers, so that is good. So for the domain of this guy, I would say for this region right here that x has to live between -1 and 0. Okay, so I write it like that. And because when I plug in -1 and 0, it ends up being 0, I can take the square root of 0. So I'm going to do equal to. Okay, so that gets rid of this bit right here. Now this bit means that anything that it's bigger than 1, I can plug in. So also, x can be greater than 1 or equal to 1, and that's what my entire domain is going to look like for this function. That was really, really gross. Really gross, okay? So only numbers that are between -1 and 0 or numbers that are greater than 1 are numbers that I can plug into this and be safe, meaning I have a positive number and he doesn't have any problems, okay? Kind of gross for that one, all right? Now let's bop over to here and let's talk about some domains. So first of all, we have that, let's talk about the division by 0. We know that this number down here, whatever that guy is, that he cannot be equal to 0. So I know for sure that x squared minus 1 cannot be equal to 0 because that would give me 0 in the bottom. So I just solve it from there. X squared I know can't be equal to 1. And if I take the square root of 1, no square. The square root of 1 is plus and minus 1. So I know that x, for my domain, x cannot be plus and minus 1. X cannot be equal to +1, -1, because if it was and I plugged a +1 and a -1 in here, this entire thing on the bottom would end up being 0, and I cannot have that. All right, I'm going to erase some of this stuff so I don't have it quite quite as yucky. All right, whatever. All right, next thing that I need to worry about is having this square root have a negative inside of it. So I'm going to do kind of the same procedure as it was over here. It's not going to be as much work as it was for the last example that we did. So what I'm going to do first is to check this. I always set the inside, this guy equal to 0, and then we end up doing a number line. And the beautiful thing about this one is the first thing that I'm going to do is I'm going to multiply the x squared minus 1 to the other side. And when I take x squared minus 1 times 0, that ends up being 0. So 3x equals 0. And if I divide by 3, x equals 0. So on my number line, I'm just looking at 0 being here. And we just have two things that we need to test. So I'm going to test a -1. Oh, wait, I can't test -1 and +1. I'm going to test, right, because we said x can't be -1 and +1. So I'm going to test -2 and +2, okay? All right, I hope that kind of made sense. We just determined that we cannot plug in -1, +1, so I'm going to test -2, +2, okay? So -2, if I plug that into this equation, 3 times -2 over -2 squared minus 1. I don't want that thing to be a negative number because I cannot take the square root of negatives. So 3 times -2 is -6. -2 squared is 4. 4 minus 1 is 3. So I have -6 divided by 3, which is -2. Not going to work. Bad. I cannot have -2 because when I plug it in, it ends up being negative. All right, let's try the same thing again with +2. So 3 times +2 over +2 squared minus 1. 3 times +2 is 6. 2 squared is 4. Minus 1 is 3. So I have 6 divided by 3, which is +2. That's correct. That will work. I can take the square root of a positive number. So in addition to x not being equal to be, or not being able to be +1 and -1, we also say that x has to be greater than or equal to 0. Okay, because numbers that are greater than or equal to 0 are the only ones I can plug in to get a positive number inside of the square root. Gross, gross, gross. Okay, so just a couple more things that we're going to go through down here. These go a lot faster. These are composite functions. These are plugging one function into the other. So we're going to do A and B first, and those ones are are pretty quick. And then C and D will end up being just a touch harder and going to be equations from there. So this guy, G composed of F of 2. It kind of looks like it says Goff, but it's not. I take and rewrite him as G composed of F of 2 like this with parentheses instead of that little composition circle in the middle. These two things mean exactly the same thing. Okay, so what this does right here is G composed of F of 2, when they have a number here that I'm plugging in, what I do is I take that 2 and I plug 2 in and I evaluate what F of 2 is first. Okay, so I need to find what F of 2 is, and that just means I plug 2 into the F equation. So 4 times 2 squared plus 1. Okay, we need to figure out what that is. 2 squared is 4. 4 times 4 is 16, so 16 plus 1, that is 17. So I have figured out that the entire thing of F of 2 is 17. And now I just need to figure out what G of 17 is. I know that F of 2 is 17, so I replace that 17 with F of 2. And now I just need to find G of 17. Okay, so I do 1 over 17 plus 2, because I'm taking 17 and plugging it in here. 1 over 17 plus 2 is 1 over 19, and that's going to be my final answer, okay? So 17 is not my answer. 17 was part of what got me to the end, but I have to do both of those steps in order to get my final answer of 1 over 19. Okay, let's do that again over here with -1. In this case, we're doing F composed of G of -1. Now we're plugging -1 into G first. Okay, so I need to evaluate G of -1 to start with, all right? So I'm plugging -1 into G, 1 over -1 plus 2. And to put together the stuff on the bottom, -1 plus 2 is 1. So this is 1 over 1, which is equal to just 1, okay? So G of -1 is 1. This entire thing right here, G of -1, I'm going to plug 1 in for that, so now I'm just finding f of 1. Okay, and f of 1 means I'm plugging 1 in for x, so 4 times 1 squared plus 1, that's what this function is right here, plugging 1 in. This is going to give me my final answer. 1 squared is 1, 4 times 1 is 4, plus 1, that's 5. If I'm going too fast, pause it, so my final answer is going to be 5. Okay, if that was too fast, pause the video, go back, watch that again if you need to. Next thing. These are the last 2 examples that we're going to do. We're going to save the rest of this for the next video, okay? So g composed of f of x. Here we don't have a number that we're plugging in. So what this means is, if I rewrite it with parentheses, g composed of f of x, that's what he looks like. What we're doing is we're taking the entire f of x and we're plugging that in to the g of x, okay? So the entire f of x, I'm going to erase some of my mess here. We're taking the entire f of x and we're plugging this entire thing into the g of x, where the x is located at, okay? So g of x is my outside function. He was originally 1 over x plus 2. That's what this guy says, 1 over x plus 2. But instead of putting x in there, I'm going to put 4x squared plus 1 in there, okay? So the f of x is just replacing the g, okay? And then all I do from there is just simplify as much as I can. So this bottom part right here, things that I can put together are the 1 and the 2. So 1 over 4x squared plus 1 and 2 combined to make 3, and this is all that I can do on the bottom there. That's it, okay? For d, this guy, if I rewrite him, is f composed of g of x, and in this case, g of x is the inside function. So I'm taking the entire g of x and I'm plugging him in to the f of x function, okay? So for this one, I'm going to erase these guys up at the top here. My f of x function, which is my outside function, was 4x squared plus 1. And instead of it being x, I'm going to take my g function and I'm going to plop it in there for that, okay? Now, if I take 1 over x plus 2 and I square it, that's like saying 1 over x plus 2 times 1 over x plus 2, okay? Or I can do 1 times 1, which is 1, and x plus 2 times x plus 2. If I FOIL that out, that will be x squared plus 2x plus another 2x plus 4, okay? Or 1 over x squared plus 4x plus 4. That's what this piece right here becomes, okay? So, almost done. We've got 4 times that 1 over x squared plus 4x plus 4, and then plus 1. We've taken this guy and we FOILed it out, and it became the stuff in parentheses right here. The only other thing that I can do is this 4 is like saying 4 over 1 times this stuff. So I take 4 times 1 on the top, which is just 4. 1 times this stuff on the bottom just leaves that x squared plus 4x plus 4. And then I have plus 1 on the end. And this is going to be my final ugly answer. But that's what he looks like. Okay, so for the parts C and D down here, we were just leaving the x the same. So when you leave the x the same and you don't actually plug a number in, you're only going to get an equation to pop out. Up here, when we were plugging the numbers -1 and 2 in, you're going to get a number to pop out. Okay, so hopefully that wasn't too confusing. That was kind of disgusting. We'll save the rest of it for the next video, and there you go.